Next, we'll be solving the last two questions, 5 and 6. And 5 is to solve the integral from 0 to pi over 3 of sine cubed x over cosine of x dx. First, we can rewrite this equation from 0 to pi over 3 of sine squared x over cosine of x times sine of x dx. And we did this because we want to do the substitution of cosine squared x is equal to 1 minus cosine squared x. And when we substitute that, we'll have the integral from 0 to pi over 3 of 1 minus cosine 2x over cosine of x times sine of x dx. And now that we have gotten this far, we can do u substitution, where u is equal to cosine of x, and du is equal to negative sine of x dx, which can be negative du is equal to sine of x dx. So cosine of x will all be replaced with u, and this will get rid of our sine of x. We can rewrite this again. And since we are going to resubstitute u at the end, we won't solve for new limits, so we will leave those blank. But we'll have 1 minus u squared over u du. And there will be a negative out front because of this. So now we can separate the fraction by splitting up the denominator, which would give us the negative integral of 1 over u minus u du. And this is very easy to do the integral of. So we would have negative. The antiderivative of 1 over u is the natural log of the absolute value of u, and the antiderivative of u is u squared over 2. And we can go ahead and resubstitute, where u is equal to cosine x. And that would give us, I'll also distribute this negative sign. That would give us negative natural log of cosine x plus cosine squared x over 2. And this would be from 0 to pi over 3. And when we solve for that, cosine of pi over 3 is 1/2. And cosine of pi over 3 squared is 1/4. 1/4 over 2 is 1/8. Minus cosine of 0 is 1. Natural log of 1 is 0. Plus cosine of 0 is 1. 1 squared is 1 over 2. So minus 1 over 2. And we'll have a final answer of negative natural log of 1/2 minus 3/8. Next, we can solve for number 6, which is the integral of 64 plus x squared, all square rooted, over x. We can do this by recognizing this as part of a triangle, where that's the hypotenuse actually, and we would have x is equal to 8 tangent of theta, where dx would be equal to 8 secant squared of theta d theta. we will solve for this separately, and then we will resume that later. So we have 64 plus 8 tangent of theta squared, all square rooted, which is equal to 64 plus 64 tangent squared theta. And we can factor out a 64, which would give us 1 plus tangent squared theta. And that is equal to 64 secant squared theta. And the square root of that would be 8 secant theta. Now we will go back here and we will plug this in here. We'll replace this x with 8 tangent theta and this dx with 8 secant squared theta, d theta. So we have 8, we have the integral of 8 secant theta over 8 tangent theta times 8 secant squared theta d theta. And that 8 and that 8 cancel out. We can go ahead and bring this 8 outside the integral since it's all being multiplied together. So we have 8 times the integral, and we will also go ahead and multiply these two secants together, where we have secant cubed theta over tan of theta d theta. Well, if we think about this, secant is just 1 over cosine. So we'll rewrite this again. 8 times 1 over cosine cubed theta. Then tangent is sine theta over cosine theta. D theta. So dividing by a fraction is the same thing as multiplying by the reciprocal. So we can say times cosine theta over sine theta times cosine theta over sine theta. And that would cancel out one of these cosines. That would cancel out this denominator. And that would give us 8. The integral 1 over cosine squared theta sine theta d theta. And if we go back to the way it was before, we could have secant again. And we can have 8, the integral of secant squared theta over sine of theta d theta. Secant squared theta is equal to tan squared theta plus 1. So we'll go ahead and write this out again. 8 to the integral. And we'll also go ahead and split up the denominator. So we'll have tan squared theta over sine of theta plus 1 over sine of theta d theta. And that is equal to tan squared theta over sine of theta is equal to secant theta. 8 to the integral of secant theta tan theta plus cosecant theta d theta. And we know that the antiderivative of secant theta tangent theta is just secant theta. So we can rewrite this. secant theta. We know that the antiderivative of cosecant theta is plus natural log of cosecant theta minus cotangent theta. Then we have to figure out how to get this back into terms of x. So if we go all the way to the beginning again, we can see x is equal to 8 tan theta. And let's go ahead and draw out a triangle. And since x is equal to tan theta, that means tan theta is equal to x over 8. Tangent is the opposite over adjacent, so we know this is x and this is 8, and that would mean that this is 64 plus x squared square rooted. And if we are trying to solve for secant of theta, cosecant of theta, and cotangent of theta, with this being theta, well, secant of theta is equal to hypotenuse over adjacent, which is equal to 64 plus x squared square rooted over 8. Cosecant of theta is equal to hypotenuse over opposite, which is equal to 64 plus x squared square rooted over 8, over x, and cotangent of theta is equal to adjacent over opposite, which is 8 over x. So we'll use this information along with what we have so far, and we'll have 8 times secant theta. Secant theta is the square root of 64 plus x squared over 8 plus natural log of cosecant theta, which is 64 plus x squared square rooted over x minus cotangent of theta, which is 8 over x. And we can go ahead and simplify this by distributing the 8, which would give us the square root of 64 plus x squared plus 8 natural log of 64 plus x squared square rooted minus 8 all over x. And finally, plus c. That's our final answer for number 6. So we have done 5 and 6.